And here's the menu for today's study hall. We're going to be doing, it's going to be a quantitative study hall. It's going to be focused on problems on which traditional algebra does not work. Someone in the text box is saying about questions submitted through chat. No, I don't know what that means. If that means this text box here, nobody sees anything in the text box until they're logged in. So, and I've only been logged in for 2 minutes. Okay, today's theme is quantitative problems on which algebra does not work. But before we get started, we've got to do some notes. I'm going to give you the usual warnings about problem submissions, but then on top of that, I've got some extra examples because people are definitely submitting things that do not correspond to the guidelines. So we'll give you a little bit more news about that. But here's the usual warnings. Let's run through this really quickly, but then I've got some more examples to show you. Okay, please do not submit problems that are too general. We're going to see more examples of this on later pages. Please do not submit problems that are too specific. This is probably the biggest offender. Please do not just submit a single problem and ask about a couple of choices. That's what our forums are for. And our forum responses these days are pretty quick. Like, we'll probably answer those questions within about a week or a week and a half at most. So if you've got one problem to ask about and one question to ask about it, just ask on the forums. Here's the address of the forum, manhattangmat.com/forums. Also, personal issues. If you have personal study plan issues to post, please submit those also on the forums. We have a folder called General Questions. That's what that folder is for. If you have a question specifically about B-School admissions, we have one folder in the forum called Ask an Admissions Consultant. That's where you submit those. So what we'd like to see is topics of intermediate depth. If you're unclear what constitutes a topic of intermediate depth, go ahead and take a look at a few of the past recordings, because the topics that have been chosen for those recordings, for the most part, are topics of intermediate depth. So one of the questions that we picked last 2 sessions ago, for example, was I need help on stats questions involving the median. So it's a good question, but oh, whoa, who's doing that? Okay, time to take a whiteboard away from people. Okay. Please do not mess around with the things on the board. Thank you. Okay. Please tie things into more general questions. So if you do ask about a single question, please ask some sort of general question that pertains to it. Otherwise, we're just going to tell you to kick that question over to the forum. Also, probably most importantly, if you submit a problem, you have to cite the source of the problem. You have to. If you don't tell us where a problem is from, we cannot answer it here. Because remember, there's copyright issues surrounding problems. So we got to tell us where it's from, original source. So here's what I mean. Okay, first thing, by the way, a lot of people have been submitting problems that are already covered in past study halls. So in the last 2 weeks, a lot of people have especially been doing this even more than usual, so I felt like addressing this here real quickly. If you go to the Thursdays page, it's the same page that you have to go to, I think, to sign up, so you should all know where this page is. If you go to the Thursday Study Hall page, then what you will see is a list of archived recordings. And it lists all the topics of the previous recordings. So in some of the old recordings, I said that you should email for this list. Now this list is posted. So in particular, here are some submissions that people sent in the last couple of weeks that are already on there. So one person said this. I've practiced a lot of reading comprehension but haven't been able to answer questions. That's already the topic of 2 study halls. So you should check the archive and make sure that your topic is not already there. Someone wrote, could you do coordinate geometry questions? There's already a study hall where coordinate geometry is the main theme. So if there's something that you want to see that's not in that session, then you should specify that. Otherwise, the response would just be check the archive April 1st. Same thing, someone wrote, I would like to translate word problems into equations. That's general word problem hints. So that's in December 17th. So again, you go to the Thursday page, listed all of the previous archives, check it out. You're probably going to find a lot of what you are looking for already in there. Because I would say, I mean, we've got a lot of study halls already. I would say probably a solid 40% of the stuff that people submitted this past couple of weeks is stuff that is already here. So be aware. Smiley face if you guys are okay with this. Smiley face icon if you know where to find this thing. The easiest way to find it, if you don't know where to find it, you can Google this term that I just wrote in the text box. You can Google Thursday with Ron, and it'll be the first hit that comes up. Okay. Also, submissions that we can't or won't use. Let me show you a few examples of these, just so that you know what we're talking about. Again, all of the examples on this page are submissions from the last couple of weeks. These 3 questions are just, I'm showing you these because these are questions that are way too specific, and so these would be better for the forum. For instance, this person is just asking about one verb on one page of the strategy guide. I mean, this is fine, but there's a place for that, and it's not the study hall. The place for stuff like that is the forum. So if you're asking about one question off of one page of a strategy guide, you'd go to the forum, you'd go to the strategy guide folder, and you would type that question. This is one absolute value question. The person is just asking about one question. This is on the forum. In fact, this exact question is on the forum 3 or 4 times. So if you search for it, you'll find it. Just admittedly, this might be a harder question to search than some others because there's not a lot of words in it. But if you do type these symbols into a Google search, you could find threads about this problem. But also the other 2, these 2 submissions right here, we can't use these anyway because nobody told us where they're from. This is really, really important. You can't just say a practice test because we don't know whose practice test it is. And you can't say nothing. Like this person didn't tell us where this problem is about, or where it's from, sorry. You gotta, first of all, you gotta give us the whole problem. You gotta give us answer choices too. So don't just give us the question like these 2. Give us the answer choices, please. But you've also gotta tell us where the question is from. Not forums and not just a practice test. You've gotta give us the source. This is really important because otherwise we wind up on very thin ice with respect to copyright. Also, ask a more general or broad question. Okay, this person did sort of do that, in that, and because. That's still specific enough to be posted on the forum, though. So this is, in fact, I know this issue is posted on the forum in more than one place. So if you can't find that, you can always send a quick email. Then there's these. I hope that you guys understand why these questions, we just can't possibly use them. Can you explain what the OG does not explain? That's a lot of stuff. It's not really something we could do in one study hall. What are the math and verbal strategies we can use for GMAT? That is basically everything that we have ever taught. So we definitely can't teach everything we've ever taught in one study hall. And then how do I solve critical reasoning quickly? That's an attempt to do like all of, like these bottom two, we cannot cover all of critical reasoning in a single study hall. So please don't submit things that are like this. There's nothing that we can do with that. I mean, for critical reasoning, we have a 300-page strategy guide for a reason. And that reason is there's no way that we can cover that in one study hall. Personal study plans, please don't submit stuff like this. This doesn't belong on the study hall. This belongs on the forum in the general folder. That's why we have that. The general folder is for things like study plans and personalized advice. Study hall is not the place for that. Also, another solid 20 or 30% of people are doing this. Please do not submit OG questions. We cannot use them. Okay, if you submit OG questions, we just have to ignore them. Unless those questions are also on GMATprep software. If they are, fair game. But OG problems we can't use. Okay, smiley face everyone if this makes sense. And we will move on. Okay, one person's asking in the text box about basics. This is every other Thursday, and there's more information about it in the page if you Google it. If you got here, you must have been on this page already, though, because that's where you sign up. So, but the other basic information is here. Okay. Smiley face, again, give me a smiley face again if all of this makes sense. Again, please don't submit problems like this because we can't use them. So these kinds we just cannot do on the study hall. And then these we have our hands tied if you don't give us a source. And then if you're super, super specific, that's why we have a forum. So again, make sure that you submit the kind of questions we're looking for. Like this is a good kind of question. This is nice and medium-sized right there. This is not so broad that it's ridiculous. Like it's not I need help on word problems because there are so many kinds of word problems. That's just not a reasonable request for one study hall. But at the same time, it's also not a single question. So this person and about 4 or 5 other people asked about the median, so we did the median about a month ago. This is the good scope of a question. It's not too general and it's not too specific. And I mean, you don't even have to post a specific problem along with it. You can just say stuff like this and this is perfect. I mean, I can go ahead and take problems from elsewhere if necessary. Okay, any questions about these submissions? Again, please don't do anything that looks like, I mean, these, I just realized I spelled submissions wrong up there. Please check the archive. We get about 30 of these a week, these repeated ones, so I don't have time to respond to them individually. But if your topic is already in the archive, we're probably not going to do it again. So just FYI. And then again, please don't do any of these things. All right, if you have questions, please type them in the text box. Otherwise, we're going to get going on the problems for today. So let's do it. Okay, let's give it a shot. You should see A through E multiple choices. They should have appeared just now, right there in the corner. So here's a problem. When you answer this problem, please do not answer the problem in the text box. In fact, because I'm in a good mood today, I'll even show you a picture. Okay, you should see this on your screen. Smiley face if you see these buttons on your screen. Okay, you should see them. They might not be in that exact arrangement of shape, but you should see this sort of thing. Okay, please answer the questions using those buttons and not in the text box. Okay, go ahead and try this problem. I'll give you 2 minutes and change. Go for it. Okay, we've used up 2 minutes and 15 seconds, so please in the next 15 seconds go ahead and guess. Remember, I can't force you to guess, but this is the GMAT. The GMAT doesn't let you leave questions blank. So if you leave it blank, you're not preparing yourself for the kind of thing you're going to have to do. Okay, we're still waiting on about 5 people. Alcides, Dan, Christine, Ruby, and Victoria. Okay, I'll give you 5 more seconds. Again, even if you have to make a wild guess, please make a wild guess and use these little indicator buttons. Okay, if you just came in, then no sweat. Okay, let me call time. Here's the statistics. I will tell you that one of these majority answers is not the correct answer. The correct answer is not one of these 2. Okay, if any of you just came in, again, there should be 5 buttons over there that say A, B, C, D, E. Over there in the corner, you should be able to press those so that your answers are not public. Okay, let me tell you what the story is here. In particular, the answer is not B and it's not C, so a bunch of you guys fell into some traps. Remember what today's theme is. Today's theme is problems on which traditional algebra is not going to work, which means that a lot of people are really, really going to do some learning today. Because one thing I've discovered in teaching this test is that a lot of students think that traditional algebra can do everything all the time. And unfortunately, the truth is that it can't. So, can't. How about that? So, here's the problem. Let's talk about it. You got purple and orange chips. Okay, so you can at least write these as equations. So, let's do that. The first one winds up giving us that 5p plus 7n is 53. Second equation winds up giving us that 6p and 3n is 42. Okay, now, everybody, smiley face if you understand how we got these equations. I'm making some assumptions here, but other face if you don't. If there's enough other faces, we'll talk about it. Okay, we're good on that. All right, let's talk about statement 2 first. Statement 2 you can do with algebra. So, I mean, the question is asking us what is the combination of 2p plus n. So notice this is a combination. One thing, if you take our class, you'll see this, so I'll give you a very short version of it. The short version is that this is a combination. It's not just p and it's not just n. It's a combined version of the 2. So, since it's a combination, you should be aware that you should first try to find the whole combination at one time. So with statement 2, we can actually do that. If you look at statement 2, statement 2 is 6p plus 3n is 42. Let's take a look at it. Our goal is 2p plus 1n. So, and notice that we're not going to do that. The goal is to get 2p plus n. So does anybody know what we can do to get to that goal from the given statement? If you do, go ahead and type in the text box. You can divide both sides by 3. So let's do that. Alright. If you divide both sides by 3, or you can factor out 3. Victoria is doing that. A couple of other people are doing that. Same sort of deal. So if you do that, then you wind up with 2p plus n is 14. This is sufficient. Notice you don't even have to calculate this number. You could just say 2p plus n is some hard value because the number itself is irrelevant. So there's a lesson to be learned here. It's not the major lesson of today, but there's a lesson to be learned here is when you have a combination, don't depend on finding the individual variables. Because in a lot of cases, you just won't be able to find them. Like, for instance, here you can't find P and you can't find N. But you can still find the combination that you want. You can still find 2P plus N. Okay, smiley face, if that statement makes sense, it's sufficient. Now we'll move on to the other one, which this is where it gets a lot more interesting. Okay. Now let's talk about this. This is fun stuff right here. So there's, okay. The first thing you should do is realize that in that statement, you're not getting a combo. Like, there's no way this statement is going to give you 2p plus n in a single instance. Because unlike the second statement, there's no math operation that you could just do here. So, there's no magical math operation like division by 3 that will give the answer. So does that mean this is insufficient? Does anybody have insight into what's going on here? Yeah, there's an additional restriction here. So, but additional restriction. Like, notice these are casino chips that are worth integer numbers of dollars. So that can't be neglected. Because if people say this is insufficient, I mean, you could divide, the question in the text box is, could it be divided by 3? You could, yeah, but there'd be no reason you would want to, because this would be 5/3 p plus 7/3 n is some god-awful number. So that would, no, you wouldn't want to, but if you wanted to, sure, you could knock yourself out. But here there's no reason to. Okay, this is an additional restriction. The additional restriction is that they have to be integers. And so the major takeaway from this problem today is that if a quantity is restricted to whole numbers, then you have to be willing to test numbers. Algebra is not reliable. You have to be willing to test values. This is the main takeaway from this problem. Like, if you've got an integer restriction, because algebra, the problem is that algebra doesn't know if numbers are integers or not. It can't tell. Like, there's no way that algebraic operations will reject solutions that are not integers. So, like, if you look at this with a purely algebraic standpoint, you're going to say there's not one solution, but the problem is that that's not valid in the case of an integer restriction. So what you've got to do is you've got to just set it up where we're going to test values. So we know that 5p and 7n, whatever those are supposed to add up to 53. So the only way of really telling whether this is going to work or not is by just trying them out. So someone tell me in the text box what values could 5p have? Could be 5. Could be not just any integer, huh? It's got to be 5p. So yeah, it's got to be 5 or 10 or something like that. These have to be, because remember, and it can't be 0. Remember that you do have to use some sort of common sense when you filter these things. You're not allowed to have like a casino chip that's worth $0. So or negative integers. So this could be 5. It could be 10. It could be 15. It could be 20, 25, 30, 35, 40, 45, or 50. We don't need to go any higher than 50 because then you're over $53. So, but then we got to try the corresponding values of 7n. So if 5p is supposed to be 5, then what would 7n have to be? Text box. If this were 5, this would have to be 48. You have to subtract it out of 53. So that doesn't work because that's not a multiple of 7. 43, 38, just take all these away from 53 and see what you get. Notice it's not good enough to just find a solution because this is a data sufficiency problem. You have to verify that there is only a single one. But remember that the problem is that this has to be a multiple of 7. Like 7n can't be numbers like 48 and 43 because those are not multiples of 7 chips. So 48 doesn't work, neither does 43, neither does 38, neither does 33. 28 works, so there's a solution. Then 18 does not work, 23 does not work, 13 does not work. 8 does not work. 3 does not work. So it looks like we've only got one way of doing this. So that is sufficient. Algebra is not going to tell you that. There you go. So this is the main takeaway here. Remember, the theme of today is problems where algebra strikes out. So this is one of them. If you've got a whole number restriction, your algebra is not going to be reliable as far as sufficiency goes. Because you're not going to reject all the values that you're supposed to reject that contain stuff like fractions. Okay. Any questions about this problem? Notice this is supremely important because this means if you see these kinds of equations with any sort of integer restriction, and that includes implied integer restrictions. Like here they come out and tell you it's an integer, but they certainly don't have to do that. They could also just say it's n boys and n girls or something like that. Then you got to test the values. So, I don't know what mentioned in the pass means. Pass. Sorry, there's a question in the text box that I'm not understanding. Okay, if you could rephrase that question, it'd be great. Okay, let's look at another one. Yeah, the key indicators is this. You got a whole number of restriction in the problem. So they either might come out and tell you that, or they might just imply it. Like if you have p boys and n girls, then even if they don't actually tell you integers, those are still integers because you can't have like 6.4 boys. So. Question in the box, can you use what you know to help solve the first one? No, you can't. Very basic data sufficiency question. You might want to go check out the first unit on data sufficiency again, but no, these statements are independent. So the only time you would ever put the information together is if they're not sufficient alone. So you don't do that here. Okay, any other questions about this problem, please type them in the text box. Otherwise, we will move on to another question. Okay, yeah, but you treat them separately. I mean, that's not data sufficiency. You don't put them together unless they are insufficient. So if that's an issue, make sure to check out. Like, okay, the basics of the way data sufficiency works. First, you evaluate this alone. Then you evaluate this alone. You don't ever put them together unless they're both insufficient. So that's basic facts about data sufficiency. If that's unclear, then go check out the real basic introduction to data sufficiency. And then that'll make more sense. So the final answer to the question here is D, because they're both sufficient. All right. So is there any way to solve this part of the problem without trying numbers? No, there's not. So that's the only way to actually figure out that this is sufficient. I mean, unless you use like absurd amounts of graduate level number theory. But yeah. Okay. Let's move on to another one. Here's another question. This is from gmatprep. If any of you don't know, gmatprep is the official test prep software from the guys who make the test. So this is real. This is official. This is the real deal. Give it a shot. I'll give you again about 2 minutes. Okay, we've killed about 2 minutes and 10 seconds again. So in the next 20 seconds, please answer, even if that means guess. Okay, I don't know how long you guys have been in the room, but there's about 3 or 4 people who aren't answering yet. So please give me something, even if it's a guess. Okay, here are your statistics. Someone's asking about, yes, these are archived. All the sessions are recorded. The recordings will be on that same page where everything else is at with the other information. Okay, you guessed it. This is another problem where you have to plug like crazy. So it's another, I mean, it might help you to write as an equation. I think a lot of people like to look at equations better than they like to look at words. So it may help to rewrite this as an equation. If you do that, let's say your integers are, I don't know, A, B, and C. Then you get A squared plus B squared plus C squared is 75. The exponents will show up in a second. There's an exponent. There's an exponent. There's an exponent. Okay. I mean, this is not really, again, something you're going to be able to solve with algebra. I think at least you could probably look at this one relatively quickly and say, no way. So you guessed it. You got to do this by plugging. Really no other way to do it. You got to just go through and be organized. So again, this is an equation with an integer restriction. In fact, it's a perfect square restriction. Can't really do algebra. So you have to plug. I mean, notice the key element of plugging here. Here's the last problem. The key element here is it's not like it's hard to plug numbers, but when you plug numbers, you just have to be very organized about it. You can't use random combinations of numbers. So you got to have some sort of method to your madness, because otherwise you can just be flailing around for a really long time trying to plug random numbers. So when you plug numbers in, make sure that you have some sort of organization behind the way that you're doing it. So, because here the organization that we used was, let's just look at all the possibilities for 5p and then go from there. Here's one way of being organized here. I mean, it's not the only way, but I'll show you one sample method that'll work here. So, but again, we're working at the same theme here, which is that when you plug numbers, you have to be organized. So each of these squares, these are all perfect squares. So each of the a squared and b squared and c squared must be one of the list of perfect squares. So there's your exponents. Each of those numbers has to be one of the numbers in this list, because those are perfect squares of integers. And you can stop at 64 because the next one is bigger than 75. So we just need to organize somehow. Let's have an organized approach. How about start from the biggest one, examine all possibilities, and then work down. So let's say, could one of them be 64? Well, if one of them is 64, the other two would have to add up to 11. If you look at these pods, you can get 1 and 9, but you can't, that's 10, it's not 11. You can't make 11 from two of these numbers. So 64 doesn't work. So then you can go down, could one of them be 49? That would mean that your other two would have to add up to 75, take away 49, subtract 50, add back 1, you get 26. You can make 26. That's 25 plus 1. So there's your three squares, 49, 25, and 1. So your three numbers have to be 7, 5, and 1. So there you go. Notice that, I mean, you've got three different numbers here, so if you use any sort of organized approach, the chance that you're going to find this is pretty high. Because you know, if you're doing this, then if you work from the bottom up instead of the top down, you'd get it. In fact, if you started with 1 first, you would find these possibilities right away. The thing you got to do, though, is you just have to have some sort of organized approach and not, like, totally freak out. So you want to realize that there will be problems where algebra doesn't fly, and you have to be prepared for that sort of eventuality. Any questions about that? Type them in the text box if you've got them. Again, the signals here are pretty clear. The signals, at least, that you're going to have to do this sort of thing are that, as last time, you've got an integer restriction. So restricted to whole numbers, you can't just play around with equations. You've got to just start plugging. And I mean, the key is to be action heroes here. I mean, like, you can take a look at this for a few seconds and realize I have no algebra that will handle a 3-variable quadratic equation. I mean, there's just no way. So as soon as I see this, I should turn tail and start to plug. There's a question of, are these kinds of things regularly asked? I mean, they won't happen every other question or anything, but chances that you'll see at least one or something on your test, yeah, you'll see one. I mean, because again, that's what this test is about. That they don't want to write a test that people can ace by just doing algebra. That's actually kind of their point here. They really don't want someone who is very one-sided to get the highest quant score. So like if you are really, really good at doing algebra, but that's all you can do, then they don't want you to score a 51 on quant. That's kind of their whole point. They want to make sure that people are flexible and versatile and can take a number of approaches to things. So yeah, there will be spoiler questions like these, and there will be quite a few. Okay, let's try another one. Take a crack at this one right here. Again, please use the numbered answer. Please use the lettered answer choices. Yeah, because I love you guys so much. I'll put the picture on the board again. But There you go. Please use those. This is a little bit longer question, so I'll give you about 2.5. Go for it. Okay, next 20 or 30 seconds, let's try to get an answer to this guy. Remember, we're already over 2.5. So, it means if you've got an answer, you've got an answer. Okay, waiting on a couple of you guys. I'll see this. Amelia, GMAT taker, KL, and Tima, you might have just gotten here. So, okay, here are your statistics. These are the answers that you gave. So we're kind of all over the place on this. Let's take a look. So this is one of those problems where, I mean, the reason that you can probably tell that you're not going to get anywhere with algebra in this problem is because there are like 7 quantities in the problem. So in problems like this, it's really more about drawing blanks and filling them in. So this type of problem in which you have lots of different quantities with some fixed sum, and you're manipulating them all at once. This doesn't respond very well to algebra. Because, I mean, you would have to define some absolutely ridiculous number of variables. So instead, if you see this sort of problem, make some sort of visual representation, like a series of blanks. And then fill it in. Without trying to define, I mean, in case-wise, look at extreme cases, because those are the most interesting. I mean, if you can find extreme cases, then you don't really have to worry about the cases in between. So let's take a look at how we would do this. First of all, let's make sure we understand the question, because this question is sort of weird. If you're relatively new at data sufficiency, you may even have some issues with just understanding what's going on in this problem in the first place. But did store S sell more than 11 copies on Friday? So that means what we're doing here is must be more than 11 would be sufficient. So that would be sufficient. If it must be 11 or less, that would also be sufficient, because that would be a no answer. But could be more than 11 or less than or equal to 11. That's insufficient. So again, I got to put a line down there. Okay, now that's a correct statement. So these are the two possibilities. When you have a yes or no question, again, if this is review for you, that's good. But make sure that you know how to process this kind of thing. If you have a solid yes answer, that would be sufficient. This would be a no answer, that would also be sufficient. This would be an I can't tell. That would be insufficient. So smiley face if you guys understand that much. You may not know exactly how to solve the problem, but tell me, smileys, if you get that this is what constitutes sufficient or not. Like, you don't have to find the number of copies. You just have to tell how it relates to 11, basically. So let's look at this. Let's make blanks. Just make 7 blanks. So Sunday. Text box, I know some of you from other countries. Does your week start with Sunday or does it start with Monday? How would you guys rather do this? I don't really care. So would you rather start your week with Monday or start it with Sunday? in your text box? Go ahead and tell me. I think I see more Mondays. Let's go ahead and start with Monday. So if you start with Sunday, just change it accordingly. So here's Monday, here's Tuesday, here's Wednesday, here's Thursday. Start with Saturday. Saturday, maybe Saturday guy. Are you in Saudi Arabia? Like I know your guys' weekend over there is Thursday and Friday. So okay. All right, well, there's our week. So if you want to make your blanks differently, then, yeah. Okay, go ahead and do whatever suits you. So here's some blanks. Number one, here's a story. Store S sold 8 copies of the book on Thursday. And also notice that Saturday was the most, and Friday was the second most. So we should definitely keep track of all that. Okay. Someone typed in the text box, that does not matter. Go ahead and tell me what you're talking about, because I don't know. All right, so here's what we're doing here. Total of 90. Let's look at statement 1 first. Did they sell more than 11 copies? Well, we know that they sold 8 copies of the book on Thursday. And then this is what you're interested in. It helps to diagram this kind of stuff and actually make it explicit. So the question that we're asking here is this thing more than 11, or is it less than or equal to 11? Okay. All right. Does anybody know how we might approach this? Because, I mean, any sort of algebra here is going to be a little bit shaky. So how might you approach this sort of thing? Remember that extreme and borderline cases are what we are most interested in. So borderline cases meaning cases that are on the edge of the range. So what are the, someone said, let's try to make this 11. Okay, let's try to make that 11. So remember, we're most interested in Friday. So let's try 11 on Friday. And let's see what happens. So 11 on Friday would mean that we have, if Friday is 11, there are 90 minus 19, 71 books left to distribute. And I mean, as long as we can distribute 71 books somehow, we're good. So given that Saturday is all you have to do is find something that works. So someone in the text box is saying that you can assume neither statement is sufficient. No, you can't, because actually one of them is. Okay, so you got 71 books to distribute. You just got to find some way to distribute 71 books. So let's do it. The best way to do that, given that Saturday has to be the most, if Saturday is the most, then you could ensure that'll happen by putting how many numbers of books in these other slots. Text box. Yeah, small numbers, as little as they can be. So number 1 on Monday, 2 on Tuesday, 3 on Wednesday, and 4 on Sunday. Then you've still got 61 books. Okay, so we're happy there. All right, now, so we got this. We've got the case of being 11 or less. What number should we try now? Yeah, you gotta try. I mean, remember though, a couple people in the text box are saying, what about Friday being 9 or 10? As soon as we figure this out, we are fine. We don't care about 9 and 10. Because remember, the only issues that we care about are, can we get more than 11? Can we get 11 or less? That's all we care about. So as soon as we make 11 work, we don't care about 10 or 9 or 8 or 7 or 6 because those are the same case. That doesn't help us anymore. Like, we're only trying to get a yes and trying to get a no. So we've got this. So now we only try to get numbers above 11. So let's try that. Let's try to make it 12, borderline cases. So then we can still do the same thing. We can still go 1, 2, 3, and 4 on Monday, Tuesday, Wednesday, and Sunday. And then that means we've got 60 on Saturday. So we're good. So color coding wise, there you go. Can be either way, so that's insufficient. Okay, smiley face if you guys follow this so far. Okay. All right, now let's try statement 2. See how this winds up. Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday. Okay. So we still got to have, now we got to have 38 books on Saturday. So that's 38. That's still the most. Same issue that we're doing here. We're trying to figure out whether these can be more than 11, less than or equal to 11. So this is the same issue on Friday that it was before. So let's try. If we want to try for 11, let's do that. Same way we did last time. So try 11. Now, what do we know about these numbers? Remember, this is the second most books. So what do we know about these numbers? The rest of the numbers. Fun fact, they've all got to be smaller than 11. So this is the most you can have here is you can have 10 or less. You can have 9 or I guess fewer because it's books. 10 or fewer, 9 or fewer, 8 or fewer, 7 or fewer, 6 or fewer. So if you add all that up, that adds up to 11 and 9 makes 20, plus 10 is 30, 45, plus 44 is only 89. So this doesn't work. You're stuck with 89 books or fewer than 89. Can't work. And if you use a number lower than 11, then you'll have even fewer books. So, given that this is impossible, you're not going to get a number less than or equal to 11 in this box. So this means that in this case, you're going to have more than 11. And so that's sufficient. Someone said they're having trouble with what we wrote here. Remember, you got to have different numbers of books on every day. And these have to be the 2 biggest numbers of books. So you got to go down from 11 because you can't have numbers that are bigger than these 2. So that is the biggest you're going to get is 10, 9, 8, 7, 6. You can't make the numbers any bigger than that. You can make them even smaller, but then that wouldn't achieve our goal here. So question asker, go ahead and let me know if that makes sense to you. Okay, any questions? So again, algebra not happening. If you get this kind of thing, you just got to plug away at it. Someone's asking about how long should this take you. I mean, if you look at the irony here is that all of this stuff is like literally grade school math, but these are some of the hardest problems on the exam. It really all depends on how fast you are at algebra. Sorry, not algebra. It depends on how fast you are at arithmetic. So, I mean, if you are fast at arithmetic, you could probably do all of this in a minute, minute and a half. If it takes you longer to do arithmetic, it'll take you longer. The key, though, is just to realize that this is what you have to do, and you have to just get going on it. You can't sit there and stare at it. You gotta be an action hero. That's the key. Any questions? Questions? Okay, let's do another one. Bang. Okay, this one's a little bit shorter. I'll give you about a minute and a half. Again, you know the drill. Please use the cute little letter buttons. Please don't indicate answer. You guys have been good little schoolboys and schoolgirls today. But okay, there you go. Give you about a minute and 45. Go for it. All right. Let's get an answer to this pretty soon. No, it is not. It's actually, the Y is not a typo. Okay, we're still waiting on, I don't know how long Dan, KK, MDLE, I don't know how long you guys have been in here, but remember that the GMAT makes you guess, so. All right, you guys are in for a good time on this one. This one's fun. They're all fun. Okay. So out of 49 people here, one of these people is me, so that doesn't count. So out of 48 people, looks like one person got this right, because the answer is A. Take a look. This one's good times. All right, so if you are that, I'm not going to name names, but if you're that one person, you are an all-star. Okay, let's take a look. It's sort of evil. Again, algebra isn't really going to help you with these, like, tricky, people are typing an easy one in the text box who didn't get it right. So that's interesting. Okay. Again, okay, guys, please, first of all, don't talk about problems being easy or simple or whatever, because that doesn't really help anybody. And what's funny is the last 4 people who called problems easy have all gotten all 4 of them wrong, including this one. So please don't do that. All right, let's talk about it. These guys, these are also equations that algebra is going to strike out on. So another type of situation in which algebra is either difficult or impossible is what I'm going to call like cute little equations or inequalities that involve properties of numbers. And they're not going to tell you that they involve properties of numbers. You have to kind of learn that through experience. So what is the property of numbers that applies all over this question? Remember, when we say properties of numbers, we're talking about like odd, even, positive, negative, integer, fraction, stuff like that. Like what does all of this have to do with? Like, so one of you typed it, let's see if a couple others type it. Like what property is central to all this whole thing that's going on here? Yeah. All right. Now let me add, okay, this all has to do with signs. Okay, all of this has to do with signs. Let me ask a really stupid question. How many signs are there? Yeah, there are not 2 signs, there are 3 signs. The unknown doesn't count. Unknown is not a sign. There are 3 signs. There is, in big fat 40-point font, there's positive, there's negative, and there's our friend Mr. Zero. 0 is a sign. When you think about signs, don't forget about 0. Okay, this is a big, big, fat, huge deal. Because, I mean, this is not an unimportant exception. Like, the GMAT won't write problems that deal with, like, stupid exceptions to things. But 0 being an exception to sign rules is not an unimportant little trivial thing. I mean, this is a big, big deal. So, statement 1 is absolute value not equal to the original number. So that's, I gotta put the slash through the equal sign, so that'll happen here in a sec. This is statement 1. Yeah, no, okay, someone's typing in the text box about fractions and stuff. This problem's got nothing to do with things being fractions, but other problems will. In this problem, it doesn't make any difference, really, because these problems don't change if you make x a fraction. The same properties are still true. So this problem is purely about signs. But yeah, these could be fractions. You're correct about that. But here it just doesn't matter. Like, all of these things could be fractions. Yeah, they could be pi, they could be 1/5, they could be decimals, whatever you want. So, sure. Okay. Let's just see, well, try the 3 signs. Positive, negative, 0. If x is positive, then these will both be the same number, so that's not going to be true. If x is 0, this is 0, and this is 0. So 0 is not equal to 0 is false. But if x is negative, then it works. So there you go. This means that this is really just an obnoxious way of saying that x is negative. Okay. Someone in the text box is asking about rational numbers. You don't have to know what rational numbers are on this test, but no. I mean, some numbers are things like pi and square root 2. So, no, numbers don't have to be rational. Statement 2 says x is equal to the opposite of its own absolute value. All right, let's try the 3 signs again. Okay, the difference this time, okay, positive still won't work. Like, if you try to plug in, 1/2 or 3 or 10 or some other positive number, then the left-hand side will be positive, right-hand side will be negative. It won't work. The difference this time, though, negatives still work, but if you plug in 0, 0 also works. Like, if you plug in 0, then negative 0 is still 0. 0 equals 0. That's a true statement. It works. So this means that x could be negative or 0. And that turns out to make all the difference in the world on this problem. So now let's examine the statements. We don't know anything about why, but someone tell me a fact. Remember, there are 3 signs, not 2. Someone tell me a fact about y squared in the text box. What do we know about? Even if we know nothing about y, what do we know about? Some of you guys are still typing it has to be positive. It's not true. I mean, remember there are 3 sides. This is not a joke. Like, if you ignore the fact that y squared could be 0, you're going to get burned a lot. So we know that y squared could be 0 or positive. It does not have to be positive. It is really, really important. So this is either positive, even if we know nothing about y. So y squared is either 0 or positive. In this statement, x is negative. So that's sufficient because a negative number is always going to be less than a number that is 0 or positive. So, right, that's a sufficient statement. If you have questions about that, go ahead and toss them in the text box. The difference this time is that someone's asking very complicated questions in the text box. Go ahead and email me that question. The short answer is no. I mean, I think you're misunderstanding the can't contradict thing. But I don't want to sidetrack the study hall, so go ahead and email that question to me. Here's the email address. Okay. This one is again either 0 or positive. This one is 0 or negative. So I can't tell anymore because there's that single possibility that both of them are 0. So insufficient because if they are both 0, you get a no. And in any other case, you get a yes. So the answer is A, and we have a single solo vote for A. It's very tricky. Okay. Any questions about this problem, go ahead and type them in the text box, please. Otherwise, we'll move on to another one. Okay, let's see. It's good stuff. The question is, why can't x be 0 here? Because if x is 0, this is not true. If you try 0 in this statement, it says 0 is not equal to 0, and that's false. So it doesn't work. Okay, let's try this one right here. Go for it. Give you a timer. There you go. Okay, please try to answer this one in the next 20 or 30 seconds. By the way, you guys are being good sports about the time management here. In previous study halls, a lot of people are reluctant to answer the questions, but yeah, you're good sports here. All right, I'll give you another 10 seconds or so to give an answer to this. Okay, here are your statistics. This time the class did pretty well on this. I'll give you the quick rundown. It's still definitely not a majority. It's still only about a third of everybody, but so these are all tough. because of the algebra not working. This is another one of those little cute equations that I talked about before that algebra does not solve. This is another one of those. This one is absolutely impossible to solve with algebra. It can't work. This is another little cute equation. Beware of little cute equations. What I mean by that is if you have some big, long, ugly thing, then chances are you're going to be able to solve it with algebra. I mean, you know, there's not going to be some super big, long, ugly equation that also is not doable with algebra. But many of them can't be solved with algebra. We made that point before, such as this one. Instead, the only way you can really solve this is, annoyingly enough, by actually spelling out all the different ways in which this could work. So if x to the y is equal to 1, someone, I know there's going to be an avalanche in the text box, but someone tell me some different ways that x to the y could equal 1. There's 3 different possibilities. Remember, you need to at all times think about both values. So, okay, if x to the y equals 1, the first possibility is that x might be 1. So 1 to the anything. You can raise 1 to any power at all and get 1. So, in other words, x equals 1 and y equals any number. Since it has to be integers in the problem, we'll stick with integers. But if you raise 1 to any integer power, even like the negative 2,643rd power, then it's still 1. That's one way of doing that. There's another way of doing it, which is that it could be, even if, 1 to a negative power is still 1. Another way to do it is to raise any number except 0 to the 0 power. Right. In other words, x is any integer except 0. And then y is 0. Okay. If you need examples of these, then you can try them yourselves. But for example, 1 to the negative 2,000 power is still 1. If you're not sure on negative powers, you can check out our number properties book, and then we'll give you a little bit more information about that. In our Foundations of Math book and in the number properties book, they tell you about that. In this case, if you take something like 3,435 to the 0 power, this is 1. Infinity is not a number, so you can't consider. Someone in the text box is talking about infinity. Infinity is not a number, so you don't need to consider that as a case. Okay, then there's one more case. Who knows what that is? It's not just these 2 possibilities. Who knows what the last case is? Some of you guys are typing. We've got any number to the 0. Yeah, there it is. It could be negative 1 to an even integer power. So, if you raise negative 1 to an even power, then then you get 1. So, if you're looking for an example of that, then as an example, if you take -1 to the like 16th power or something like that, then you get 1. So any of these could work. So now we've got to think about how the statements restrict these things. So statement 1 means that, who knows, in the text box, what does it mean if the product of x and y is negative? What does this mean? Yeah, it means one's positive and one's negative. So it either x is positive, y is negative, or x is negative, y is positive. So that rules out statement 2, case 2 here, but case 1 works with case 1. The first of these cases, this works with case number 1. And this works with case 3, as long as the even integer is positive. This works with case 1 as long as the exponent is negative. So this is insufficient because x could be either 1 or -1. Like if you're looking at case number 1, then x is 1. If you're looking at case 3, then x is -1. So we can't answer the question. That doesn't work. On the other hand, statement 2 means y is odd. The only place where that can happen in case 1, because in this case y is 0, which is not odd, 0 is even. And in any case, all that matters is that 0 is not odd in this case. And then in this case, y also has to be even. So in this possibility and this possibility, y is an even number. So y is odd rules out anything except this. So we don't know what y is, but we do know what x is. This means that x has to be 1. So that's sufficient. So in this case, the takeaway that you want to get from this problem, the lesson that you want to get, is that some cute little equations require you to break down the possibilities case by case. It's not really fun to do that, but sometimes it has to work that way. Okay. Quick questions, throw them in the box. Let's go for one more. We can probably slam one more problem into here. So try this one. I'll give you about 2 minutes again. You know the drill. All right, boys and girls, let's try to answer this one in the next 15 seconds. Still waiting on about 6 of you. Remember, if you got a guess, that's how the story goes. All right, yeah. Okay, there's a Thomas who hasn't answered. I think everybody else is on the block. Thomas, no love? No love from Thomas. Okay, so here's the statistics. All right, this is pretty good. There's no majority, but the answer with the most votes by a hair is actually the correct answer this time. That would be E. I'll give you the quick rundown, but first I'll give you the lesson, and then we got a jam here. This is an awfully weird restriction. I mean, it's just weird. I mean, how often do you multiply the digits of a number, right? So like the lesson here is if you see a really weird condition or restriction on the problem, and you can tell that there aren't many possibilities, what do you think you should do? Text box. Yeah, all you got to do is, it sucks, but you have to make a list. So, because I mean, you can tell, you should be able to tell that there aren't going to be a whole lot of ways to do this. Because 8 is not a very large number. So I mean, there's 3 ways to multiply 3 numbers together to get an 8. All right, those are, you can have a 1, and an 8. You could have a 4, a 2, and a 1. Or you could have the 2 or 3 of a kind going on here. So you just got to list them. You can do 118, 181, 811. You can be organized again. 124, 142, 214, 241, 421, 412, 421. And then here's our spoiler friend, 222. So be organized. Don't make lists at random. Like, it's worth it to take a few extra seconds to make an organizing principle. Oh yeah, this is easily doable in 2 minutes. I mean, this is only 10 possibilities. So even if you take a full 12 seconds to think of each possibility, you're still good to go. So, okay, statement 1, because once you make this list, see, here's the deal. If you make an exhaustive list, then once you're done, you are literally only going to just pick things off of the list. So, I mean, because with a condition as weird as this, like, what else are you going to do, really? I mean, what else are you going to do with the 3 digits multiplied to give me 8? I mean, it's not like you're going to be able to do any traditional math of any kind with that. I mean, well, what would you do? So once you've got the list, the advantage of, yeah, it's a little bit time consuming to make the list, but once you've got the list, you can literally just pick numbers off the list. So statement 1, the hundreds digit is even. That could be 811. It could be 412, 421, or 222. So that's insufficient. Or actually, the 200s could work too. So you could also have the 214 to 241. It's actually every single one of them except for 124 and 142. And then statement 2 allows only 811 and 222. But if you, unfortunately, that's still insufficient because there's 2 possibilities. But then if you throw them together, guess what? They still both work. So, still insufficient. So E like elephant. All right, there you go. So, excellent. We're done. We're actually a little bit over time. So let's call it a day. If you have like 3 or 4 minutes of administrative questions, I will take them. Otherwise, you guys are out of town, and I will see you in 2 weeks. Any quick questions? Meaning quick. We'll take them now. I'm going to shut off the recording at this point, and If not, if you guys are going to log out, you can just quit the application. You don't have to wait for me to log you out. You can just quit. There's no log out procedure. You just leave. So have a good day, and see you in 2 weeks.